Alright, we're going to talk about lactones, the structure and nomenclature of this functional group. Intermolecular esters of hydroxycarboxylic acids, they are called lactones. Lactones are also known as cyclic esters. So if we look at a general structure of a lactone, this would be one R group. We have the carbonyl carbon. We have O, and you can cycle all of those carbons on the end, it doesn't matter. This would be considered the other R group. So, in a sense, a lactone is a cyclic ester. Now, let's make some quick notes about lactones. Lactones, and we'll talk more about this when we get to naming, has a carbonyl carbon, and the carbonyl carbon is going to be bonded to a double bond O, doubly bonded to oxygen. The second thing is we're going to have two single bonds in the cycle bonded to oxygen. Two single bonds in the cycle bonded to oxygen, and one of these single bonds will be the carbonyl carbon. One will be the carbonyl carbon, and the other will be the what I call terminating carbon. Okay, so you recall when we were naming carboxylic acids, a lactone is a derivative of a carboxylic acid. We started counting at the carboxylic acid. So for numbering with respect to naming, your carbon is going to start counting. What I meant to say was at the carbonyl carbon. So we start counting at the carbonyl carbon, and we want to go in the direction that gives us the oxygen last. Okay? So in this case, we're going counterclockwise. Okay? So we want to get to the oxygen last. So our terminating carbon, the length, the most or the maximum number of carbons that we have 5 carbons. in the lactone. Okay. So this has to be the structure of a lactone. We have to have a cyclic ring. We have to have one of the oxygens bonded to the carbonyl carbon, and the terminating carbon, and you'll see what I mean by that when we look at carboxylic acids, has to be bounded to the oxygen as well. So this will distinctly give us intuitive information as to how to name these compounds. Okay? If you have a structure where the carbonyl carbon is not directly bonded to an oxygen, and that oxygen is not directly bonded to the terminating carbon in that ring. Recall, we want to get to the oxygen last when we number, starting at the carbonyl carbon. Then we do not have a lactone. Okay? So let's look at the carboxylic acid compared to a lactone, because the naming comes from a carboxylic acid. Now, another feature of a lactone will have the word hydroxy in its name. Okay? It will have the word hydroxy in its name, and it will also have some type of carboxylic acid. Some alkanate acid. Alkanic acid, if I can use that word. So you know, when you did a 4-carbon chain with no substituents, C double bond OH, 4-carbon chain, we call it pentonic acid. So your lactam will have a similar alkanic acid, and the last name of the structure, last name will be lactone. Okay? The last name will be lactone. So let's look at an example of exactly what is actually going on with these molecules. So now I'm going to switch, and I'm going to draw out the carboxylic acid. We have already learned how to name carboxylic acid. Okay? So this is double bond O. This is OH. Let's see, let me put a NH2 here. And I'm going to put 2 Cls. right there. Okay, so the formation of a lactam, let me talk about that right quick. Your hydroxy, the intermolecular hydroxy carboxylic acid, this oxygen actually forms a bond with the carbonyl carbon. Okay, and through some catalyst, this happens. So what we lose in the lactone, we wind up losing the H, and we wind up losing the OH from the carboxylic acid. Okay, now if we were to name this carboxylic acid, we would say we would have an amino on 3. We have, let's number this, 1, 2, 3, 4, 5, 6, 7. And we have a 5,5 dichloro. And we have a hydroxy on carbon 7. So this would be 3 amino, 5,5 dichloro. These are the names that we're putting in alphabetical order. And what do we have left? We have a 7 hydroxy, heptonic. I have 7 carbons. That's going to be a heptonic acid. Okay? So we have already learned how to name these molecules. We've already learned how to name carboxylic acids. Okay? So a carboxylic acid derivative through some acid catalyst reaction, I'm going to draw the corresponding lactone. Okay? So let me see, can I draw the corresponding lactone? So we're going to have 1, 2, 3, this. So let me put my double bond O here. Let's say we have 1, 2, 3, 4, 5, 6, 7. Okay, that's going to work. We have 7 carbons. Now, if I lift this carbon like that, with the vertex of those 2 lines, it would be a carbon. Okay, now I can do 2 things. I can write O over the vertex, which changes that to a oxygen. You'll see it one way, and another way you would see it as this. Either way is acceptable. So you can draw out your cyclic structure and not have to erase. You can just write over the vertex of where you want the oxygen to be, and that will do. Okay, so remember, this is a oxygen and not a carbon. Okay, on carbon 3, I'm going to put the NH2. On carbon 5, I'm going to put the 2 Cl groups. Okay, so if I name this, I have 1, 2, 3, 4, 5, 6, 7. This would be again 3 amino, 5, 5 dichloro dash 7. So this bond from the terminating carbon of your carboxylic acid to this oxygen is going to be named hydroxy. Okay, the last part is going to be heptonic acid, and because this is a lactane, I have to write lactone. All right, so we can kind of see how the lactone is derived from the corresponding carboxylic acid. Okay, now this issue with the terminating carbon, uh, the terminating carbon here in carbon bonded to the hydroxy group here is going to be the N carbon bonded to the oxygen. Now we have another case where if that terminating N carbon of the lactone contains other carbons, then we have to count that as the longest chain. Okay, let's see what I mean by this. Let's draw out a lactone. Okay, so this would be a carbon, but now I'm going to put O on it. So now that makes that a oxygen. I'm going to draw a methyl group here. And I'm going to put an oxygen. I'm going to put a bromine. And I'm going to put a chlorine. Okay, so this is going to be carbon 1. This is going to be carbon 2. This is going to be carbon 3. That's going to be carbon 4. Now notice that that terminating carbon on 4 that's bonded to the oxygen, it has another carbon bonded to it. So I have to label that as 5. If I had an ethyl group, I have to name that as 6. If I had a propyl group, I would have to go out to 7. So this is only for that terminating carbon on your lactone that's bonded to your oxygen. Okay? Now, let's see what we have. We have 2 bromo dash 2-chloro. And do not forget your hydroxy. Where is the O in the lactone? Is bonded to carbon 4. So we're going to write 4-hydroxy. And all of this is in alphabetical order, the way we want it. Now, I have 1, 2, 3, 4, 5 carbons. So this is going to be a pentonic acid. That pentonic acid is going to be a lactone. Okay. So this closed intermolecular ester of hydroxycarboxylic acid, this lactone, it has to take the name of the corresponding carboxylic acid and add the word lactone at the end. Now, just for fun, if I gave you this structure and I said, ooh, what's the name of the corresponding carboxylic acid? Well, it would be 2-bromo, 2-chloro, 4-hydroxy, pentonic acid. That would be the open chain. Now, you can draw your open chain with the same amount of carbons. So, the bond breakage, and let me open this up a little bit. Let's see, double bond O would be here. 1, 2, 3, 4. That would be 5. So where this oxygen is, it will revert back to an OH. Where this double bond, your carbonyl, it would now be bonded to an OH. So this is your carboxylic. Did I do it right? 1, 2, 3, 4. Nope. That one too many. So you always have to double check your number of carbons. And then that would be the CH3 here. That made carbon 5. So let's just transpose these onto one another. That would be carbon 1. This is carbon 2. This is carbon 3. This is carbon 4. That's carbon 5. And remember, your OH is lost from the carboxylic acid. Now we have regained it. And H is lost from your hydroxy group. We have now gained it. So this is the lactone on this side. And this is the carboxylic acid. Okay? Now, let's look at a case where we don't have additional carbons on the terminating or the end carbon in the cyclic lactone. Let's see how we would name that. Okay. And it's quite simple because it will be named as any other type of substituent. And I'm swapping it up. Sometimes I put the O on the vertex and sometimes I'll write the O in. I want you to be aware of both cases, no matter how you see it. So I'm going to put a methyl group here. And remember, for your lactones, your carbonyl carbon here has to be bonded to this oxygen, and that terminal, and I say terminal 1, 2, 3, 4 within the ring, has also to be bonded within the intermolecular ring. It has to be bonded to that oxygen. So I have 1, 2, 3, 4, 5 actually. And now I'm going to put this group on carbon 2. So what happens here is that what's on carbon 2 is treated as a substituent. Okay? Notice that my N carbon within the ring, okay, 5 is the actual N carbon that continues after the ring. But the N carbon within the ring bonded to this oxygen is carbon 4. Okay? So on carbon 2, I have a 1, 2, 3, I have a propyl, 2 propyl. On carbon 4, I have a hydroxy. Okay, so this is going to be 4 propyl, 4 hydroxy, 4 hydroxy, 2 propyl. What is my longest chain? 1, 2, 3, 4, and then 5. So this is going to be pentonic acid lactone. All right. Now, as a part of your homework, I want you to, this is number 1, break the lactone back into the corresponding carboxylic acid. Okay, that's problem number 1. Okay. I'm going to do another example. Okay, so we're going to name this lactone. Start with the carbonyl carbon. 2, 3, 4. So this is going to be 3 aminos. Okay, do not forget that your hydroxy is connected to this terminal intermolecular 4 carbon, so 4 hydroxy. And how many carbons do I have? 4, so it's going to be a pentonic acid, lactone, excuse me, Lactone, lactone. Alright, so 2, I want you to do the same. Break into the carboxylic acid. Okay, now I'm going to do another example similar to this one. Note 1, 2, 3, 4. Okay. My last intermolecular carbon is 4, and it's bonded to other carbons. So I'm going to do 5, 6, and 7. Okay. So what do we have? Again, we have 3 amino. But now this is going to change. We still have our 4 hydroxy. But we have how many carbons now? 1, 2, 3, 4, 5, 6, 7. So that's going to be heptonic acid lactone. Okay, so number 3, break up. Break it back into the corresponding carboxylic acid. That's problem 3 that I am assigning you. All right, let's look at another one so you can get the hang of it. It's quite simple when we know the rules. The text does not do enough in explaining, so that's why I'm putting this together. Now, first let's examine, is this a lactone? Is my carbonyl carbon singly bonded to an oxygen, and is that oxygen bonded to a end intramolecular carbon? Why, yes it is. So this is a lactone. 1, 2, 3, 4, 5. Okay. The end intramolecular carbon has additional carbons bonded to it. Okay, so this is going to be 6. This is going to be 7. All right. Now, I'm going to put a amino group on here just to get you in the practice of naming. So at carbon 2 we have an amino, 2 aminos. Alright, on carbon 3 we have 1, 2, 3. We can go that way. We have 1, 2, 3. We can go that way. It doesn't matter. Complex, substituent, or branching. The first carbon off of the branch is 1. This is 2. This is 3. So my base of that branch, 3 carbons, is a propyl. Okay? Now, what is coming off of number 1? I have 1, 2. So that's going to be 1 ethyl propyl. So 2 amino, 3 dash. When we do complex constituents, we open parentheses. 1 dash ethyl propyl. Close the parentheses. And we're still going by what? Alphabetical order. Amino, ethyl propyl. Now, what's next? Do not forget about our what? Hydroxy group. What carbon in the intermolecular ring is that hydroxy group attached to? Why, it's attached to 5. So 5 hydroxy. Now, what's different in this case? I have 1, 2, 3, 4, 5. The N carbon in the intermolecular ring has 2 more carbons attached to it. That's going to be 5, 6, and 7. So that's going to be a heptane. When we change it over to a carboxylic acid, we say heptonic. And acid and lactone. Okay? Now, you will see quite a few of these on the exam and a couple on the quiz. So notice how this is different from this structure. Double bond OO NH2. Notice how it's different from this structure. The only thing that is different is you have 1, 2, 3, 4, 5. Everything would be the same. 2 amino, 3, 1 ethyl propyl, 5 hydroxy. Instead of heptonic acid, we would have pentonic acid. We don't have any additional carbons attached to the N in a molecular carbon. So this would be, write this out, 2 amino dash 3 1 ethyl propyl 5 hydroxy, and that's going to be pentonic acid, lactone. Okay. Now, so this would be, what was this? 3, 4. Break into the carboxylic acid. Okay. So if you break it into the carboxylic acid, if you want to do the open chain cyclic structure like I did here, that's fine. Or you can make the straight chain structure, doesn't matter. You should be able to recognize both. All right. Now, that was number 4. Number 5. Name the following lactones. So, I want you to name this one. I want you to name this one. Seven, we're going to name this one. Eight. Number 9, name this one. Okay, and then I want you to compare number 8 and number 9. Are they similar? If so, explain. Okay. Compare 8 and 9. Are they similar? If so, explain. Why? Okay. Alright, so let me double check and make sure everything's a lactone. I did not leave off a double bond O. Okay, so this will help in your preparation for the exam. This is pretty straightforward. The next functional group we will name is the lactams, Lactam, and it includes nitrogen rather than oxygen, a derivation of an amide for that functional group. Okay. Now, have an idea for number 10. For number 10, draw 4 lactones that have at least 3 substituents and their corresponding carboxylic acids. So the lactones that you draw, I want the corresponding carboxylic acids that they correspond to. And when you draw the carboxylic acids, I want the straight chain and the I call cyclic open chain. So your straight chain would be something like this. Your cyclic chain would be something like okay. Draw both of them to get in the practice. So you have a assignment with 10 questions that you can complete relatively easily.